Did I have to go through this? My events? Try again. I don't know. Okay. What am I doing? There we are. 1, 2. Okay, hello. What we're doing is we're going to talk about the abacus. And so what I'm doing is I have 1, and then 2, and then 3, and then 4. So that's 4. We notice what 4 looks like, right? So what we're doing is we're reading the abacus. When we read the abacus, we'll know how to understand it, and then we're going to do some adding, subtraction, multiplication, division. So the first thing we're going to do is we're going to do 1. So this is 1. That's 2. This is 3. That's 4. Now, what's after 4 is 5. After 5, I'm sorry, this is 5. 5. The top beat will always be 5. And then we have 6, 7, 8, and 9. So notice if I did 1 and I add 5, now I have 6. If I have 2, so I've done 2 before, and I add 5, now we have 7. And then if I have 3 and I add 5, now we have 8. If I have 4 and I add the 5, now I have 9. Does that make sense? Let me know in the comments if you have any questions. So what we're going to do is we're going to read the abacus again, because when we understand how to read the abacus, we will be able to do some adding, subtraction, multiplication, and division. So here's my ones. I have my ones, my tens, my hundreds, my thousands, my 10,000. So I'm going to look. I have my ones. So that's 1. This is 2. This is 3. This is 4. This top bead, I'll always have 5. And because it's 5, then we have 6, 7, 8, and 9. Welcome, everybody. Welcome. So that's what we're going to do is when we understand. So we have 9. So all of this is 9. This is 9. That's 9, 9, 9, 9, 9, 9. These are all 9s. So what does that mean? So what that means is all of these would be counted. When you look, we have our 1s, our 10s, our 100s, our 1000s, and our 10,000s. When we look, we have 10, 20, 30, 40, and then 50, 60, 70, 80, 90, and 100. 100, we know what 100 looks like. 100 looks like this, 100. Anybody have any questions, let me know. So what we're doing is we're learning how to read the abacus. When we read the abacus, hello, Jake. Welcome back. Thank you so much for liking my lives. Welcome back. So what we're going to do is we're going to read the abacus. Again, we'll read it 1, 2, 3, 4. After 4 is 5. 5, 6, 7, 8, 9. But because we have 9, now if I add this, it would be 19. If I have this, it would be 29. And then we just keep going. This is 39. And then this is 49. And then after this, we have 59. And then 69, 79, 89, and then 99. 99. So when we look at it, this is 99. And then if I add one more, this is now 199. So if I said 100, that would be 100. Now notice 100 looks very similar to this. I'm going to, oh, good luck with your root canal, Jake. Good luck with your root canal. So, but thank you for stopping by. So we have 1, and then this is 1. But if you notice, if all of these were 1s, then it would look like this. Oh, maybe I should do. No, that's too much. That's too much. So what we're going to do, there we go. So if all of these are touching the horizontal bar, we have 1, 1, 1, 1, 1.11. That's what this is. Why? Because anytime the beads are touching this horizontal bar, this is being counted. So because it's touching the horizontal bar, these are all counted. Now, when I do this, this is now separated, not separated. This is now zeroed out. Because this is zeroed out, none of the beads are touching the horizontal bar. The horizontal bar is what tracks the numbers. Anybody have any questions? Let me know. But what we're going to do right now is we're going to learn how to read the abacus. When we read the abacus, we count, right? All of this, if I did this, all of this would be 5. This would be all 5. And then if I did this, this is all 4. Because why? These are all touching. But then when I clear it out and I did this, then it's only this. This is 9. because this is 9, then we have 10. After 10, we can do we can count by tens. So this is 10, 20, 30, 40, and then 50. Okay, thank you so much. Thank you so much for joining. Let me know if anybody has any questions. So what we're going to do is let's do a puzzle. You guys want to do a puzzle? Okay, here's a question. So in the chat, what number do you think this is? What number do you think this is in the chat? And then maybe we do a maze. What number do you think this is? In the chat, go ahead and put in the number. So if I look, I have my ones, my tens, my hundreds. And if I look at it, this would be 3, 1, 2, 3, and this is 1. So right here, the answer is 5, 6, 7, 8. So this would be 813. And when we look, we have 813, 813. So that's our hundreds, our tens, and our ones. When we're reading this, what we want to do is we want to learn how to read the abacus. To learn to read the abacus, we're going to count it. 1, 2, right? This is 2, and then this is 3, this is 4, and then after 4, we have 5. 5 will always be the top beat. Whoa, can't see that. 5 will always be the top beat because this is 5, and then we have 6. So we have 5 and 6, and then we have 7. This is 7, 5, 6, 7, and then this is 8. 8 looks like this. 5, 6, 7, 8. Notice it's 3 beads on the bottom and 1 bead on the top. So now we have 8, and then we have 9. All of this together is 9. Does that make sense? Anybody have any questions? Let me know. If not, we're going to continue to what is NPC? Non-player, I think it's a non-player, right? Non-player, what is NPC? Non-player something? What's an NPC? Non-player companion? Companion? I don't know. I don't know. What is an NPC? All right. So, okay. That was that. All right. Anybody have any questions? Anybody have any questions? Thank you. Thank you. Non-playing character. Ah, I said companion because I don't know. All right. So let me know if you have any other questions. We're going to count on the abacus. Thank you so much for liking the like. All right. We're going to count again. 1, 2, 3, 4, and then we have 5. After 5, we have 6, 7, 8, 9, and then we have 10. After 10, we have 11, 12, 13, 14, and then we have 15. After 15, right? Does that make sense? After 15, we have 16. So notice it's the same pattern. We have 6, right? We have 6. This would be 66. 6, 5, 6, 5, 6. And then we have 7, 5, 6, 7. And then 8, 5, 6, 7, 8. And then we have 18. And then 28. And then 38. Anybody have any questions? Misfit, do you have any questions? Because I feel like I'm by myself. Hollow, are you still here? So, okay. So the first thing we're going to do is if we look at it, this would be 3, 4, 1. I'm following along. Okay, good. Why in the middle? See, I like that. I don't get it. Kit Kat, welcome back. Okay, so why in the middle? Now, the reason why we do it in the middle is because I have this horizontal bar. I'm sorry, not the horizontal bar. I have my ones indicator. This is my ones indicator. So it tells me where the ones is. This is my just a dot indicator to tell me where my ones is. Now what's going to happen is if I want to, I could go here, but if I move, that means I would move my place value. And so my place value is now ones, tens, and then hundreds, but I have no more columns. So that's why I don't start here because I want to have more numbers. So that's why I would start here. And then notice if I have my ones, tens, hundred thousands, 10,000s, then I can do here, which is my decimal. My decimal sits between my ones and my tenths. So that means I have my tenths and my hundreds, and now we have decimals. So Kit Kat, when we read it, we want to read the abacus. We have our 1, 2, 3, 4. Are you tracking like a horizontal bar? Because the horizontal bar is what tracks the numbers. Excuse me. So what tracks the numbers is the horizontal bar. This is the beam. This is the reckoning bar. So what it does is this is 4. Does that make sense? So when we do 4 and then we have 5, The top beat will always be 5. Does that make sense, Kit Kat? The top beat will always be 5, no matter what. So if I do 5, 5, 5, 5, 5, these are all 5s, 5, 5, 5, 5, 5, right? Yeah, makes sense? So now when I do 5, I want to add 1. Now I have 6. So if I add 2, right? 5, 2, 5 and 2 is 7. 5, 6, 7. So now we're just counting. So we do 3 and I add the 5. Now I have 8. If I do 4 and I add the 5, now I have 9. That's it. Well, I don't know what that means. So, hey, Harold, welcome. Let me know if you have any questions. That's so smart how it works. Yeah, it's very elegant. It's very elegant. I'm doing well. I'm doing well this afternoon. Hello, Tony. Thank you so much for the heart, for the rose, Misfit. So let me know if you have any questions. Like, please, I'd like to know that somebody else is out there. What would you use this for? I would use this for adding, subtracting, multiplication, division. So that's what it would be. It'd be adding, subtracting, multiplication, and division. And the reason why is because it's very visual. It's very visual. So because it's very visual, right, we can actually see and we do it. How does the decimals work? The decimals just means another place value. So there's a place value over here. So that's all it is. So when we look at it, we have $1, right? Let's say we say $1 and then $1 and then $1.11. Can you put a number? We can guess the number. You know what? Thank you, Aubrey. But you know what? Maybe you'll be better if, how about we do a maze? Can we do a maze? So this is a worksheet that I created to help to help do some bead recognition. So what number do we think this is? Can we do that? Where is my, oh, there it is. Okay, so if I have this number and I go here, this, and that. Is that right? 88, let's see. 800, 5, 6, 7, 8, and then 5, 6, 7, 8, and then 1, 2, 3. Yes, exactly. No. No what, Tony? That doesn't make sense to me. So, yes. So we have 883. So we have the next one, if we have this one, and then that. Tony, I'm not sure what you're talking about. Let me know. All right. Dang, I thought I wasn't correct because of the place value. Oh, you know what? The place value is like this. The place value is like this. So our ones place happens because there's a dot indicator. So we have our 1, 2, 3, 5, and then 5, 6, 7. So yes, 357. So we could do 357. I'm going to follow my maze. Now, if you look, I have my dot indicator, right? My dot indicator tells me this is the ones place. So because this is the ones place, right? I have this number, this, that, and then that, right? Ooh, almost, Tony, almost. 62. Yes, 62. I feel smart even though, I'm sorry. I feel smart even though we're learning numbers. Oh, yeah, right? No, but see, that's the thing. Once we learn how to read the numbers, then we can do adding, subtraction, multiplication, division. So this is 8, 5, 6, and then this is 2. 862. Yeah, perfect. 862. So now we go here. Internal mapping is kind of crazy. Okay, so what number is this? That, this, and then that. This is so fun, right? Thank you so much. Thank you so much. I appreciate that. This book is available on Amazon. I just made this book too. I have 2 digits and I have 3 digits. I still got to publish a 3-digit one. Yes, 780. 780. Does the ones place automatically stay there unless there's a decimal? 780. Exactly. Oh, the one stays here because I have an indicator. I have a label. This is my label. So because of my label is here, I could move my label. Sorry, I could move my label to this one over here if you really wanted to. But I like to use this one so I have because I have more numbers. 600, 5, 6, and then 1. Yes. Yes. Thank you. 610. So the label of the ones um is what am I trying to say? It's adjustable. That's what it is. It's adjustable. Okay, so we have four, 1, 2, 3, 4. We have five, and then 1, 2, 5, 6, 7, 8, 9. Yes, so we have 459. Great. Yes. Does that make sense, Tony? So it is adjustable. It just depends, and I can show you when we're over here. I'll show you what happens when we get a bigger abacus. So we have this one, that, this, and then that. 5, 9. So 5, 6, 7, 8, 9, 5, and then 5, 6, 7, 8. Yes, 958. So we have to remember that there's a 5 here. So 5, 6, 7, 8, 9, 5, and then 5, 6, 7, 8. Ah, and after we learn how to read this, then we can start going into adding and subtracting, multiplication, division. So the idea is it's very visual, and I'll show you how visual it can get. So this number, and then that. Hey, Babel, welcome back. Oh, I'm so slow I can't type it before everyone else already has. Oh, misfit. Funny. So we have this 1, 2, 3, and then we have a 0. Fun fact, I'm a teacher. I don't know this. It's actually crazy. Fun fact, this is a forgotten tool, and I'm trying to tell the world. Lynn, I do, Babble. I do. I take like small naps. 5, 6, 7, and then 3. 1, 2, 3. So 300, 307. Thank you. So we're going to do 307. Tony, what grade do you teach? This is that, and then this. Power naps. Yes, power naps. I do power naps. uh, but I feel like I'd still need to be on so everybody understands what the abacus is. The world of the abacus. Good job, Misfit. Well done. 452. Thank you, Aubrey. Yes. Thank you, Andrew. We have 450. Okay, what's after this? This, what do we do? We do 1. Thank you for the follow. Hey, Muru. Welcome back. Huh. Yeah. Ooh, see, Misfit, you know how to type fast. You can type fast. Thank you, Babel. Thank you, Andrew, Miru, Misfit, and then Aubrey. Yep. 195. 195. Tony, what grade do you teach? I'm a second and fourth grade, but also an instructor for other teachers. Hey, that's very interesting. Let me know. Andrew, you can do 0 if you want to, but it's okay to put in just 86. So this is 80, and then this is 6. So this is very good. So I know that there's a lot of math manipulatives, but this is the ultimate math manipulative. Yes, this is the forgotten tool, and I'm going to call it that. It's a complicated charter system. It usually is. So my final answer is uh, uh, uh. Yes. Thank you. That's it. That's what we're doing, and that's the end. That is the end of our maze. 406. Okay. So Tony had asked the question: is like, does it matter where our decimals are? No, it doesn't. It doesn't matter where our ones place. It's not the decimal. It's the ones place. It's a lot easier than calculus. It is easier. You know why? Because it's very visual. So what's going to happen is if I look here, I have and the difference between the two is not because it's colorful. The difference is because size matters, and this is 13 columns. So this is 13 columns, and this is only 7 columns. Because this is 7 columns, notice I only have 2 indicators. These are my 2 labels. This one, with my 13 column one, I have more labels. I can choose this one to be my ones, this ones, or I can choose any one of these. So like Pokemon, right? You want to pick your fighter, right? So if I choose this one, then right? So what's going to happen is I can choose this one, my Pokemon, and then I have my ones, my tens, my hundreds, my thousands, ones, tens, hundred thousands, 10,000, and so forth. So when I look, I do ones, thousands, millions, billions. Well, let's say I needed more number. If I needed more number, then I can start here. Ones, ones, thousands, millions, billions, and trillions. But then the problem is if I wanted to track the national debt, if I want to track the national debt, then I would have to break out my 23 column abacus. And it's the same thing. It's all the same. It's just I now have more columns. So I have my ones, my thousands, my millions, my billions, my trillions, my quadrillions, and my quintubillions. I don't know what's after. I don't know what's after four. I don't know what's after a trillion. National debt is a valid statement. Yeah, this one has been around. This one is my abacus that I've had for quite some time, and I've learned how to use the abacus for about 20 plus years. I've been teaching abacus for about 20 plus years, and then they started coming out with some plastic ones, which is good too. This one you can get from Daiso, or you can get this one. This one I sell on my. I'm trying to figure out how to get it on my TikTok shop, but I do sell this one, and it's in my bio. It's way in my what do you call it, in my on my website, link in bio. Now this is made out of plastic, this is made out of plastic, this is made out of bamboo, and it's kind of nice. All right, my coworkers have these on their boards. I never knew what they meant. Maybe this is a sign. Here's your question, Tony: does your coworkers know how to use it? That's the ultimate question. So what I can do with the abacus is we can start doing some arithmetic, which is what? Arithmetic is just a fancy word saying adding, subtracting, multiplication, division. So the first thing we're going to do is we're going to understand how to move the beads. When we move the beads, the idea is to, so what we did is we understood how to read the abacus. Oh, Tony, question: is it 1 and 4, or is it 10 beads across, or is it 2 and 5? That's the question, because it's a little different. It's a little different. If it's a 10 bead, then it doesn't use formulas. However, the Chinese abacus and the Japanese abacus, this is the Japanese abacus, we use formulas here. And I'm going to get into it, but the first thing we're going to do is understand how to move the beads. They don't have any beads. They have bars. I don't know then. I don't know what that would look like. Um, if there's no beads and it's just bars, then I don't know what it is. Unless it's like I don't know. I don't know. Okay, so what we're doing, okay, so the first thing we did is we understood how to do some bead recognition. We understood what an 8 looked like, what a 9 looked like, and then this is just like a little activity. But then what we're going to do is further back, and we're going to start learning how to read the abacus. The setup looks the same as yours on paper, so I think it's a reference. Oh, I know what you're talking about. Yes, I know those. And the bars are like, okay, hold on. I know what you're talking about. I've seen that. I've seen that, and they're like this, right? They go one hundreds. They're like this, and they go like this. And this is my ones, this is my tens, this is my hundreds. So if I do this and I do this, that's two. If I do this and then this, then that's three. If I do here, then that's four. Kind of the same. Kind of the same. I know what you're talking about. I don't teach this way. Um, because this is kind of like the 10B that goes across. So there's one abacus that goes like this, and it's like this, and you do the beads like this. It's kind of the same. Yeah. Here's another loop. They have it upside down. Okay, then I don't know. So you're saying it's like this? How do you put anything in there? Because I would imagine they fall. Unless unless you have something like this. because this is the teacher's abacus. But you just said it was bars though, so I don't know. This is the same, but the bars, the beads will stay. So because the beads will stay, right? I don't know. I don't know. That's interesting. So this is my teacher's abacus. This is my student abacus. The laminated. It's a laminated paper. Oh, you missed that part. I'm thinking like it's a real thing. I could do that on paper. I could do it on paper. I could put it sideways. Tony, that doesn't make sense. That is so that was so vague. You need to be specific. All right, all right. Get a real Get the real thing. Yeah, right. Get the real thing. Yeah. So the reason why I would recommend getting the abacus for real, because it's different when you see the picture and you see the real thing, which is very interesting. And this is where you start talking about concrete, abstract, and representational. No need to be sorry. It's just a better learning experience. I will show you. If you guys are all ready to take the red pill, I will show you the real world. So the first thing we're going to do is understand how to read the abacus. No, we're going to know how to move it. So what we did is we learned how to read the abacus. Now we're going to move it. So when I add 5, I want to add, it ain't in my class. When we add it, we want to go to the horizontal bar. When we're adding, we go to the horizontal bar, right? So now if I add 1, I want to go to the horizontal bar. So now I have the students teach me. So notice I'm going to the horizontal bar. So my horizontal bar is in the middle. I'm going to go add it. So when I add, I go to. When I subtract, I go away. So when I add, it goes to. When I subtract, it goes away. So it's the same thing, right? What we're doing is we're understanding how to move the beads. If I have 7, well, if I have 7, 5, 6, 7, I want to add the 1. All I got to do is move it to the horizontal bar. So now I have 8, 5, 6, 7, 8. If I have 9 and I want to take away 1, all I got to do is remove it. All I got to do is subtract 1. I got to move it away from the horizontal bar. So now it's very visual. It's very visual. It's very tactile. So what's going to happen is this is very simple. This is what we call simple abacus because we have enough beads. You know how Bob the Builder is. Can we do it? Yes, we can. So because we know how to add the 2, we add the 1, we can add the 2. And again, I have 5. I'm going to add the 5 to my abacus. And then I'm going to subtract, I'm going to add the 2 to the abacus. Can we do it? Yes, we can. So we're going to add 2. And my final answer is 7. In abacus, we focus on the add-in, not the result. So that's the one thing, Tony, just so you know. We don't focus on how do we make a 7. No, that's not the way we do it in abacus world. In abacus world, the real world, we focus on the actual add-in. We focus on the number that we're trying to add. So that means that when I look at it, this is why it's broken up to adding the 2. When we add the 2, right, we're looking to see what does it look like to add the 2. So if I add 2 to 7, I'm adding a 9. I'm sorry, this is now my answer is 9. So again, when I look at it, if I have 6 and I want to add 2, that's all I'm doing. I have 2 beads. My answer is 8. It's the same thing with the 3, right? And focus on the results. Focus on the add-in. So if I have the 5 and I want to add the 3, I'm only going to move these 3 beads. That's all I'm doing. When we are taking away, we take away means we minus the 3 beads like that. So then adding to the horizontal bar and taking away from the horizontal bar. So when we add 9 and we take away 2, right? We are minusing away. We're taking away from the horizontal bar. So 4 doesn't have a lot of questions, right? 4 is just if I have 5 and then add the 4. Hello, lady. We're going to do division already? Woo! We can do division, but let me write it down. So what we're going to do is we're going to add 4. Is there some way to do division other than tracking it and the remainders on the left? Is there another way to do division other than subtracting till the remainders? No, I've been doing that for years. Well, But that's what division is. Division is just it really easy to make a mistake. Well, in abacus we do it differently. So when we do the division, because when we do division, but that's the way it is though. 7 minus 11, right? So 1, 2, 3. So I'm over here and I take away, sorry, 1, 1, and then 1. My question would be who is bigger, divisor or dividend? So then we do the multiplication, right? Our divisor is bigger. So 7 is bigger than 1. So if 7's bigger than 1, then it would be 7 times what is equal to 11 or less. So 1. So I add my 1 here and I take away 7. Take away 7 is take away the 10 plus the 3. So then I have 41, but then I'll have a remainder. And then what happens? Well, who's bigger? Well, my 7 is still bigger, so then I'm going to use these two. So it's 7 times what is equal to 41? 7 times 1, 7 times 6, 7 times 5, 7 times 5, 7 times 5 is 35. And then I have a remainder of 6. So, Lady E, I would still have a remainder, if that makes sense. So it'd be 6 divided by 7. I don't know if that's what you were looking for. Gasp. I don't know if that's what you were looking for either. But but that's what it is. I've mastered abacus, but I've always been getting issues with division due to silly mistakes. If it's silly, then you're jumping too ahead, right? You're going too fast. Go a little slower. And you know what it'd be what I would do is I would keep the running total. What do they call it, like partial quotient. And so the other one, like I know when we start doing when the quotient's larger. So here's a question. Do you know how to I've mastered the abacus. So then you know how to do it when the quotient is large, right? Because sometimes the quotient becomes large. I don't know. um I don't have a question, but there's sometimes the quotient is large, so you have to take away from the answer and then go back and then add the divisor. So how do I solve it? It could just be that you're skipping steps. That's what I'm thinking. I don't know if that helps. Just practice not making mistakes. No, no. You make the mistake, go back and do it again. Go back and do it again. I figured because I learned how to do mental abacus. Yeah. You know when my kids were having a mistake, I would always tell them to go back. Don't keep doing more questions. What I would do is go back to the ones that you have a problem with, because then that will tell you what your mistake is. So you just go back to the same question and do it again. And then go back to the same question and do it again until you get it right. So don't move forward until you get that question right, because then you'll know what your weakness is. That's what my teacher told me to do too. That's what I would tell you to do. The reason why is because if you get to a new question, you're not going to have that same problem, right? So you have to go back to this to the original question you had a problem with and then figure that out, because then you'll know what things you're skipping, because it's a pattern. You have a pattern that you have that you need to figure out what is wrong. So my biggest thing was my kids when they were having problems, the biggest breakthrough was that when they had to redo that stupid question again, then they started to realize what their problems was. And because they started realizing what their problem was, they were more attentive when they did the questions. Does that make sense? So they know, oh, I know I did this wrong. I need to go do it this way. So yeah, I agree with your teacher. Oh, sorry. So we're adding the 4 and we take away the 4. So what we're honestly, it could just be been the 5 years since I did. It could be, but it's like an old. But if you're trying to do mental math after 5 years, I think it's tougher. I would always go back to the abacus. Even my kids, like it's been like I don't know 5 years for them, maybe 3 years, and they can't do it in their head. I would go back to do it on the abacus. I would always go back to do it on the abacus, because when you see it on the abacus, then it's easier to visualize. All right. So we have the adding of the 1. We do is we take away the 1. That means it's just moving the beads down. So when I add the 7, I have an 8 and I take away 1, right? That's what that means. Okay. So we've done the minus, and then what's after that? Well, after that is the plus the 5. So again, adding the 5 is just moving to the beads. And then when we do 7, we want to take away. So when we have the 1 and we add the 6, right? We have the 5 and the 6, bring it together. When we take it away, we push it apart like that. So when we have 7, I want to add 7, I move these 3 beads, one on the top and the 2 on the bottom, and I bring it together. When I want to subtract, I want to take away the beads, just like that. Does that make sense? So, yeah, I think I've lost a few people. Lady E, I don't know if you're still here, but is that what you were looking for the answer? I mean, you would have you have remainders on that one. Do you want me to go slower on that? Because it's only the 5 of us. I'm not sure if anybody else is here. Let me know. If not, we can continue. We can go into division. But if anything, we can go into more adding and subtracting. I don't know if Tony's still here. Okay, lady. Okay, so what was it that you were looking for? Here. Did that make sense? I know I kind of blew through it. So remember, we have to figure out our starting point, right? 1, 2, 3, and then we have our 1. So we know that our starting point is at 2. So because our starting point is at 2, 1, 2, and then we have to compare, right? Yeah, it seems like that people have left, which is fine. But what I'm going to do is we'll talk about this, right? So 10 plus 10, yes. So, well, what it is what are we trying to do? I made this thing. I'm so excited I get to use it. Okay. 1, 2, 3, 1. So what we're going to do is we're going to find our starting point. Our starting point is 3 minus 2, 1 is equal to 2. So my starting point will be here, 1, 2. My starting point's here. My quotient will be there. So if my quotient is there, that's what it would look like. And then what I need to do is I need to add my divisor, my dividend, 1, 2, and 3, 111. So after I do 111, now I'm going to, so notice my dividend and my quotient. What's going to happen is I take the 2, right? So who is bigger, my dividend or my divisor? My divisor is bigger. So it is what? Divisor is bigger. So it's 7 times what equals to 11. I need to do 2 numbers because my divisor is bigger. 7 cannot go into 1. 7 can go into 10. So yes, thank you. 1. So 1 is equal to 7. So what are we doing is add the 1 and I want to take away the 7. 7 take away 11. Minus the 7 is what? Minus the 7 is minus the 10 plus the 3. Minus the 10 and add the 3. Right? I'm going to move it again. So I'm here now. Whoa, minus the 3. So now my question is 7 and 4? I'm going to move up here. So who's bigger, 7 or 4? My 7 is bigger, right? My 7 is bigger. So I'm going to do 41. It would be better if it was it would be better if it was 49, but whatever. So my bigger, right? So 7 times what is equal to 41 or less? Why? Because my divisor is bigger, I'm going to utilize 2. So what times 7 is equal to 41 or less? Hey, hearts, welcome back. Thank you for the like. Hi. So 7 times what is equal to 41 or less? We just jumped into division because 5, right? 5. 5 take away is equal to 35. Take away 30, take away 5. Cannot take away 5. How do I take away the 5? I needed minus the 5. Minus the 5 is equal to minus the 10 plus the 5. So I minus the 10 and I plus the 5. So then my remainder, so my answer is 15 with a remainder. So it's 15 with a remainder of 6 over 7. Because it will be a forever remainder. There will always be a remainder because it doesn't zero out. Thank you for the gift. Does that make sense? Hey, Josh. Thanks. Okay, good. So let me know if you have any more questions. But that's the thing, right? The thing is to understand, and I really like my little contraption. I think the contraption is helpful. Somebody said, I think it was you. Was it you that said that we needed to know where the quotient was? So it was interesting. I was like, what? That's so it took some time to figure out that one. So that was the thing, is to label where the quotient would be. Cool. Cool. Cool, cool, cool. Okay, so those people that just came in, I don't know who came in, but we can read the abacus. So we do 1, 2, 3, 4, and then 5. After 5, we have 6, 7, 8, 9. After 9, we have 10. After 10, we have 11, 12, 13, 14, and then 15. We have 15. The topic will always be 5. Thank you, Nalani. Let me know if you have any questions. Thank you for the heart, finger heart. So what we're doing is we're learning how to read the abacus, and then one of the questions was like, why are we using this? Well, we're using it because it's very helpful. Thank you for the finger heart. Yeah. So what's going to happen is just to understand how to utilize the abacus to do adding, subtraction, multiplication, division. Maybe I should have like a little page that says adding, subtraction, multiplication, and division. So, I could use the back side of this. Ooh, there we go. There we go. Okay. Anybody have any questions? Nalani, do you have any questions? I know you came in. I was just wondering if you want to learn how to read the abacus, or we can do some adding and subtracting, or something. I'm here to learn from you. Oh, okay, okay. So, but do you understand how to read the abacus? So the idea is to what we're gonna do is, if you notice, we have 5. So we have 5, and then we're going to do 6. When we have 6, we have 5 plus 6. And then notice we have 2. If I have 2, 1, 2, and I add the 5, now I have 7. If I have 3 and I add 5, now I have 8. Here is 4. 1, 2, 3, 4. When I add the 5, now we have 9. And then this works very well with our place values. So we have our place value like this. Ones are tens, are hundreds, are thousands, are 10,000. Does that make sense? Let me know if you have any questions. Wow, that's cool. Oh, yeah, thanks. But it gets better because we can do adding, subtraction, multiplication, division on it. But the first thing we got to do is understand how to read the abacus. Because we have to read the abacus, then we can do the other stuff, the other fun stuff. So here's a question for you is, if I give you this number, how to read the abacus? Nope, that's not what I want. How do I... Okay, so let's do this. We have this number. How many tens and how many ones? We look on the abacus. If I have my abacus, I have my tens and my ones, right? My tens and my ones. If I have 3, how many tens and ones? We just have 3. Okay, that's easy. How about this one? This one is 30. We have 1, 2, 3. So that's my 3, my tens. And then I have 6. And that's my ones. So my tens and my ones. So this is 36. So I break it up, 3 and 6. And then I did here. So now that's okay. Okay, you know what? Let me do this one. I like my maze. I think the maze was a hit. All right, so let's do the maze. So here's my maze, and let me clean it up a little bit. This maze is no, not this maze. Actually, this maze. What we can do is we can start talking about, um, this. And so this is available on Amazon. I have it published on my Amazon. So what's this number? So what number do we think this is? If I look at it and I have this with that, what number do you think that is? Oh, thank you, Miru. Yes, 61. Thank you, Lady E. Yeah. So this started, so I have 61, and then I have this one. So my next one is, I have 1, 2, 3. Learning, where can I buy your product? This one, either my website, my link is in the bio, or you can find me on TPT. Where is my, hold on, hold please. Oh, that's right. I got to show you this one. Okay. So here's a few places where you can find me. My website, or my Teachers Pay Teachers, or here with my name. And then if you want to buy the abacus, there's a 13 column one that's available on Daiso. The 13 column one is available on Daiso. That's why I wrote that. But that's where you can find me. And my website. I guess I should put my website. Yeah. Thank you, Tracy. Thank you for asking. But yeah, oh, if you want this, I have this available for you. It's my link in my bio, and you can just sign up, and you can get this one for free. And I have it where it does the different numbers. So I have 1 to 9, 1 to 12. Yeah. So this is available on my website if you want to look into it. All right. Oh, you know what? So So with my maze, which is kind of cool, with the maze, I did a reverse maze. So hopefully this makes sense to you. And I actually cleaned it up a little bit. The question is here. I start from here. Now, I don't know what number this is, but what I got to do is I got to look at this number here, and then I got to figure out how to do 6. So I go to 60 and then 3. 1, 2, 3. And then I go here. So I just follow the path, and then I need to go to this number. So I'm going to write in 70. 5, 6, 7, and then 4. 1, 2, 3, 4. I call it a reverse maze because you know the answer, kinda, right? Does that make sense? So then after that, I'm going to this box. With this box, I need to see what's 42. So I got to color in 42. 1, 2, 3, 4, and then 2. 1, 2. I don't know if I showed this to you guys, but yeah, this is all part of the this book. Yeah, and then we're done with 42. So my next one is over here. After this is 61. So now I have to put in my abacus, 5, 6, and then that's 1. And then we have the next box, which is 85. So I have to color in 85. 8, 5, 6, 7, 8, and then 5. And then we have the next one, which is 97. So 5, 6, 7, 8, 9, and then 5, 6, 7. Does that make sense? So this is, I called it a reverse maze because you know how to get there. We just got to fill in the stuff. So here we do 90. 1, 5, 6, 7, 8, 9. This is a little harder to be interactive. That's the thing. And so I actually just published this book with this and my other maze, and with the other maze, and with this maze. So it's not a it is a 2-in-1. So there's 19 mazes, and then there's 19 mazes of these. And then there's the answer key at the back. Yeah. I just ordered mine. I'll see if I can get it ready, and because I like to see it and make any improvements on it. So, but if anybody else has any other questions, I mean, it seems like to be a very small group. Is there any specific questions, like anybody want to talk about adding and subtracting on the abacus, or you want to go through some of the worksheets, or anything? If not, right? Hey, ADHD positive. Welcome. Okay. Do you have any other specific questions about the abacus, or do you want me to just continue on adding and subtracting? We could do any question really. It's a small group. Tracy, do you have any specific questions? Any of the worksheets that I have? Was there any specific worksheets that you were looking for? Because what I do, so I have one where the maze is specific. There is a 2-column maze, and then there's a 3-column maze. And then I was going to do a 4-column maze, and I was going to do 5 columns with decimals. Nalani, do you have any specific questions? Or am I just gonna, okay, we can keep going. So, what we're gonna do is we're gonna add on the abacus. And what we did was the first thing we need to understand is how to move the beads. I don't know if Nalani's still here. Nalani, are you still here? And so, what I'm gonna do is I'm gonna add 1. Notice I'm going to add the 1. When I add the 1, I'm going to add 7 first to my abacus, and then I'm going to move the 1 bead. As I move the 1 bead, that's what I want to do. Why? Because I wanted to show how the 1 bead looks. What's going to happen is if I had 5 and then I add 2, I go these 2 beads. It doesn't matter which 2 beads. And then we have 6, right? We have 6, and then I want to add 2. I have 8. If I have 0 and I have 7 and I want to add 2, now I have 9. I don't know if Nalani's still here. I don't think she is. Lady and Miru, do you have any other questions? Any specific questions? We can do like multiplication division if we're ready. Because you guys already know how to do this. Or we could do two-step equations. We can do two-step equations. That's always been interesting to do more than just the one. So here's one that we had. It was let's see if I can find it. It was interesting. It was a good number. It was a good number. Um oh yeah, okay. So we had this number, right? 999 plus 5. So we've done this one before, right? Where we have the 9, we have 999, and we add the 5. When we add the 5, what are we going to do? Well, notice I'm going to add the 5. To add the 5, what happens? I need to, can't do it. So I'm going to plus the 5 is equal to minus the 5 plus the 10. So I'm going to minus the 5, and then I'm going to plus the 10. Notice 10 is a 1 and a 0. 1, 0. I'm going to add the 1 here. I cannot add the 1. What's another way to do it? Plus the 1 is equal to plus the 5. Can I add the 5? No, I can't add the 5. So this is not what I'm doing. I need to plus the 1 is equal to plus the 10 minus 9. So I'm going to minus the 9, and I'm going to add the 10. 10, remember that 10 is 1 and 0. Can I add the 1? No, I can't. So what am I going to do? I'm going to do the same thing. Plus the 1 is equal to minus the 9 plus the 10. So I'm going to plus the 9. I'm sorry, take away the 9. I'm going to plus the 10. The 10 is a 1 and a 0. So can I add the 1? Yes, I can. So I'm just going to add my 1. So my final answer is 1004. 1004. Anybody have any questions? Are we okay? How was that? Was that all right? That's what we call a two-step. Why? Well, that's more than 2 steps. Because we had to keep going. And that's what we did, is we just keep going until we can't do it anymore. Any questions? Wow, this is very quiet. You guys are all very quiet. Tracy, do you have any worksheets that you're looking at specific? Hello, Maddie. Okay. Anything? Okay. So we can keep going with the 2-step, or we can keep going with the what? We can keep going with the 1-step. Yeah? Okay. We had another question. Oh, you know what? Let me bring up this one. Thank you so much for liking the live, Miru. Let's see. You know what? Let's see. Okay, you know what I was trying to do is I was trying to figure out some multiplication questions. So some of the multiplication questions is trying to figure out like if they are 2-step or not. Or I guess I was going to do is I was going to break it up. So I have my multiplication. So I have like 18 times that by 5. So I have 18 times 5. We do 1, 2, 3. So I'm going to put 3 on my abacus. 1, 2, 3. So then the question is 5 times 1 is equal to 5. 5 times 1 is equal to 5. So what's going to happen? I add the 5. So I add my 5, but 5 is a single digit. So I go back one column, I add the 5. Now I have to 5 times 8 is equal to 48. So now what I'm going to do, I'm going to add the 4 and I'm going to add the 8. 5, 6, 7, 8. So my final answer is 9. So that's single. However, if I did this one, 19 times that by 4, right? We have 3. We do it again, 1, 2, 3. And then 4 times 1 is equal to 4. 4 times 1 is equal to 4. 4 is a single digit. I go back one column and I add the 4. When I add the 4, what are we going to do? I add my 4. And then 4 times 9 is 36. So I add my 3. Remember how to add the 3? 3 is equal to plus the 5 minus 2. Plus the 5 minus the 2. Plus the 5 minus the 2. And then we add the 6. So we add the 6. So my final answer is 76. See, that's an adding of the 5. Hello, Ona. Welcome. Welcome. I'm just going through math problems. Everybody else seems to be very quiet. And so I'm just going through and figuring out how to do some curating. I'm curating some math problems. Yeah. Ona, do you know how to read the abacus? I think you're the only one that's here. Okay. So we can learn how to read the abacus. What was that? Oh. Yeah? You want to learn how to read the abacus? So what we're going to do is we're going to do a review. So we have 1, 2, 3, 4. Anytime the beads are touching the horizontal bar, this is the horizontal bar. Anytime the beads are touching the horizontal bar, we are counting. So because we are counting this, yes, that is what Jeremy bought. Can you pick some up? How much is it? How much is it? Sorry, how much? Okay, so I don't know if Ona's still here, but what we're doing is we're going to understand that when we have the 4 and then we have the 5, this top bead is a value of 5 no matter what. So 5 and then 6, 7, 8, and then 9. After 9, we have 10. This is what 10 looks like. After 10, what does that mean? Well, if I had my placement value, if I had my place value, I can show you my place value. I don't know where I put it. Oh, nuts. I lost it again. Here it is. Found it. So when we look, we have our ones, our tens. Ones, our tens, our hundreds, our thousands, our 10,000. Thank you so much for liking the like. I'm so happy you're still here, Ona. You're the only one here, I think. me know if you have any questions. But what we're going to do is we're going to understand how to read the abacus. So when I look at it, this is 10, and then this is 20, and this is 30. This is 40. Does that make sense? And then this is 50. After 50, hello, Z. Thank you so much for liking the live. It's very fascinating. Oh, welcome, Lando. I'm so happy you're here. I feel like I'm just talking to just nobody. So I don't know if you're here until you make comments. So thank you. Thank you, Lando. And then what we do is this is 50. Now, why are we here? The reason why we're here is because I have a ones indicator. This ones indicator tells me that this is where I'm going to place my ones, just like I want to do Pokemon, right? I want to choose one of these dots. I can choose a label. Ooh, pick one up. Pick one up. Pick one up, please. And then so after 50, we have 60, 70, 80, 90. Now, I said that these are my indicators. This is this one and this one. It's like a label. So if this is my ones, then I know that this is my thousands. You could choose this one as your ones and you just have to move everything over. But then the problem is if I have more than tens, right? If I have 100, I don't have any more beads for, I don't have any more columns for hundreds. So that's why I actually move it to this one. So it's easier for me to have a bigger number. And then if you notice, I have a decimal. The decimal sits between the ones and the tenths. So this is my tenths and this is my hundredths. Let me know if you have any questions. Thank you so much for liking the live. And what we do is we're going to read the abacus. So this is 9999999. These are all nines. Why? Because they're all touching the abacus. They're all touching the horizontal bar. Now when I clear it, this is what 0 looks like. So if I did this number, what number do you think this is? What number do you think this is? Thank you so much for liking the live. What number do we think this is? Anybody know what number this is? Oh, oh, hey, bunny. Almost, almost. What we're going to do is we're going to look at the numbers, right? So we have 200. You're almost there. 200. And then, right. Thank you, Ona. 69. And then 9. 5, 6, 7, 8, 9. We have 6, 5, 6. And then we have this. So we have 269. Thank you so much. Thank you so much. I didn't even know you were still here. I didn't know if you're still here, Ona. So what's going to happen is when we read the abacus, right? If we did this, and then I did this, and I have that, and I did this, what number do you think this is? I have to be more patient. I don't know. I'm kind of like 800, almost. When we look at it, we have our thousands. So we have our ones, our tens, our hundreds, and our thousands. So this is, thank you, Pia. Yes, 8,130. 1, 2, 3, and then 5. Thank you, Pia. Yeah. So what we did is we're learning to read the abacus. When we understand how to read the abacus, now what we could do is we can do some adding and subtracting. Now the question is, why are we going to do that? Well, we do that because we want to be able to add and subtract. So we want to move the numbers, and what the abacus does is it helps us track our numbers. So when we look, if I have 1 and I want to take away 1, I want to remove the 1. I want to subtract the 1 from the horizontal bar. If I have 2 and I want to take away 2, I'm going to subtract away from the horizontal bar. When I have 4 and I take away 2, oh look, it doesn't matter which 2 beads. It just matters that I move 2 beads. That's what that means. So what we just did was subtracting. Save changes. Okay, yeah. So what we're doing is we are understanding how to move the beads. When I add add the 1, I'm going to take away the 1. And it's the same thing. If I want to add 3, I want to take away the 3. Notice I go away from the horizontal bar. When I add the 5, I'm going to take away the 5. I move it away from the horizontal bar. Make sense? So then the question is what happens when we want to add 4 plus 4? Well, notice in abacus, we don't memorize what 4 plus 4 is. We don't memorize this. Why not? That's the easiest thing. We don't memorize it because it's not versatile. Um. Oh, you know what? Okay, hold on. Hold, please. Actually, can you grab a couple of sheets from Jeremy? Let's make sure it's not too thick. Okay. Okay, we'll do that. So what are we doing? Oh, what are we doing? We are adding, we are going to utilize the 5. What does that mean? Well, what it means is I need to get my stuff ready. Okay. So the question is 4 plus 4. Now, if we notice, we're teaching the children how to make a 5. When we make a 5, this is what we're doing. This is what we're doing. How to make a 5. So we're teaching the children how to make a 5. What it is we're doing 4 plus 1 is equal to 5. So what does that mean? Well, this is the, what do you call it? This is the addition sentence, addition expression, I guess what you call it. So what we're going to do is we're going to isolate this variable. Why are we going to do that? Because what we want to do is we want to add a 4. Why are we trying to add the 4? Because if you notice, we don't have enough beads to add the 4. So if I add the 4 and I want to add the 4, right? There's no more beads to add the 4, right? There's no more beads. So what it means is that we can utilize the 5. What 5 are we talking about? This is the 5 that we can utilize because we can add this 5, but notice when I add the 5, it's too much. So what we need to do is we need to minus the 1. When we minus the 1, right, the idea is to make the 4 by itself, we need to subtract 1 from each side. So when we do this, we're actually subtracting 1 over here and 1 over here. So this becomes 0. So what we're doing is we're modifying, right? We're isolating the variable. When we isolate the variable, now we're given directions. What does it say? It says add the 5, take away the 1. I'm going to add the 5 and I'm going to take away the 1. So my final answer is 8. So 8 is my final answer. I need to write my 8. 8's here. Does that make sense? So what are we trying to do? Well, now if you remember, Cum- I don't know. If you understand, commutative property means that we can switch our numbers around. So if we did our number, it would be 4 is equal to plus the 5 minus 1 is the same as adding the 4 is equal to minus the 1 plus the 5. Thank you so much for liking the live. So what we're doing is we're understanding how to add when there's not enough beads. So that's what adding the 4 is. And that's what the commutative property is. And then after that, this is how we do it. Oh boy. So this is how we do it. My question is 4. So I'm adding 4 to the abacus and I want to add another 4. Notice I'm going to substitute plus the 5 minus the 1. So I'm going to substitute plus the 5 minus the 1 and my final answer is 8. So I'm going to color that in. 5, 6, 7, 8. Does that make sense? And so let's do another one. We will do another one. We could do 3. There we go. There we go. Here we go. Ah, great. So we're going to add the 3. What does that mean? Well, if you notice, my question is over here. My question is 4. I'm going to add 4 to my abacus, and I'm going to color it in. 1, 2, 3, 4. And I need to add the 3. Ah, nuts. Notice I don't have enough to add the 3. What do I do? To add the 3, I need to understand my formula. I need to understand what it is that I'm trying to do. Remember, this is what we're teaching children in school. We're teaching the children this concept. When we show them how to make a 5, Abacus actually takes it to the next level. So what we're going to do So what we're going to do is what are we going to do? We're going to isolate the variable. What variable are we going to isolate? We're going to isolate this 3. To isolate the 3, we need to make it by itself. Notice if I make it by itself and then I can't, right? I can't anymore. 5 is too much. I need to minus the 2. So here it says we need to subtract 2 from each side of the equation. So this is what I'm doing. I'm minusing the 2. If I minus the 2 here, then that means I just made it 0. So 2 minus 2 is equal to 0. So that's why I don't write it here. And then what is a commutative property? The commutative property is 5 plus 2, 5 minus 2 or minus 2 plus 5. And so this is very similar to algebra. That's why I have it here. We have so we have x plus 2 is equal to 5. So now we're talking about algebra. What we're going to do is we're going to isolate the variable. We're going to move this 2 on this side. So that's what this is. So what did we just do? We're going to add the 3. Now, if you notice my question, I still have 1, 2, 3, 4. And then what I want to do is I want to add the 3. To add the 3, I need to subtract 5. I need to substitute, not subtract. I need to substitute. Add the 5 minus the 2. So I'm going to add the 5 and I take away the 2. I sent you. Oh, thank you so much for the finger heart. Thank you so much for letting me know because I don't see it. You know what I mean? But thank you so much. I appreciate that. And then my final answer is 7. How do I know? 5, 6, 7. Thank you so much. Thank you so much, Lady J, for liking the live. And so my final answer is 7. And then here I showed you how to do it. So it's add the 5. Oh, sorry, add the 5, and then take away the 2, and that's what we're going to do. Make sense? So that is adding the 3. Let's do another one. Are we ready for another one? Okay, it's okay. I love your teaching. Oh, no, I appreciate that. I appreciate that. And let me know if you have any questions. But I appreciate that. Oh, thank you for the heart me, Lady J. Yeah, because the way the chat is, I don't see all the things because I'm on my desktop. That's why I don't see it. So what we're going to do is we're going to add the 2. When we add the 2, it's the same thing. Here's my question. 1, 2, 3, 4. So when I have my question is 4, and then what are we going to do? We're going to add the 2. To add the 2, we don't have enough beads to add the 2. So what we're going to do, first things first, we understand that we're going to do 2 plus 3 is equal to 5. And so what we need to do is we need to isolate the variable. What variable are we going to isolate? We're going to isolate the 2 because we need the 2. What's going to happen is we need to make the 2 by itself. So what happens is we need to subtract 3 from each side. So that means I got to rewrite my equation. I'm going to do 3 is equal to 5. Notice this is not balanced anymore. Because it's not balanced, how do we balance it? No, this is wrong. I need a 2. So 2, because I'm adding a 2. That's what I'm doing. I'm adding a 2. I added 2. It's not balanced. I need to minus the 3. I need to subtract the 3 from each side of the equation. So now what I'm going to do is I'm going to follow the directions. I'm going to add the 5 and take away the 3. I'm going to add the 5 and I'm going to take away the 3. So my final answer is 6. Now, if you notice, we have commutative property. What does that mean? Well, we can do 2 is equal to plus the 5 minus 3, or we could say 2 is equal to minus the 3 plus the 5. That's what commutative property means, because we can switch these two. Now, if we look, here it is again. What we want to do is we have our question is 4. 1, 2, 3, 4. So I'm going to add the 4. I'm going to add my 2. When I add 2, what do? I substitute plus the 5 minus the 3. So I'm going to substitute I'm going to add the 5, I'm going to take away the 3 like this. So my final answer is 6. 1, 6. Yeah. So now we have 1. We're actually going through my worksheet because I need to make sure my worksheet makes sense. Thank you so much for liking the live. Thank you for being here. If you have any specific questions, if not, I will continue going through my worksheets. All right. So we have our sample question. Thank you so much for liking the live. Okay, so we have our sample question. We have 4. 1, 2, 3, 4. And what it is we need to add the 1. Wait a minute. We want to add the 1, but there's not enough beads. What? So see, if I have 4 and I need to add the 1, I don't have any more beads to add the 1. What do? We have to isolate the variable. Well, what is the variable we have to isolate? So we have to circle our variable just to make sure. And so what do? To make 1 by itself, we need to subtract 4 from each side of the equation. So we can rewrite it. We do 1 equals to 5. What happens? This is not balanced. How do we balance it? We need to minus the 4. So when we minus the 4, we can follow the directions. Plus the 5 minus the 4 gives me 5. Again, my commutative property is what? I do 1 is equal to plus the 5 minus 4, or I could do 1 is equal to minus the 4 plus the 5. So what are we going to do? We're going to do it again, just to make sure we understand. So we have 1, 2, 3, 4. So we have 4 on the abacus, and we want to add the 1. Notice there's not enough beads to add the 1, so what do? I have to substitute plus the 5 minus the 4. So I'm going to substitute plus the 5 and minus the 4. My final answer is 5. That's what it is. Yeah? Any questions? No questions? Okay. I will continue to go through my worksheet because I need to edit it. I need to make sure that it makes sense. No questions? Okay. This was going to be, actually I made it like this because this is going to be part of my introduction to abacus for adults. So this is how I see it. Let me know if you see any typos. All right. So we're going to do 4, and then after 4, we'll do 3, and then, okay, well, so we'll go backwards. But now what we're doing is we're now subtracting. Subtracting is the same, but we got to do it this way. The reason why is because there's a 0, there's a minus here. And again, what is the question? The question is 5. So if I have 5 and I want to take away 4, there's not enough beads to take away the 4. So what are we going to do? Well, we have our equation. We have our addition expression. So our addition expression is minus 4 minus 1 equals minus 5. Why are we doing negatives? Well, we got to do negatives because we're subtracting, right? So what we're going to do is we need to isolate the variable. What variable? It's the minus the 4. So when we minus the 4, right, that's what we're doing. It's negative 4 minus 4, subtract the 4. So when we do it, we have minus the 4 is equal to minus the 5. But notice that's not balanced. So again, look at the pattern. The pattern is right there for us. We have minus the 4 is equal to minus the 5 plus the 1. When we minus the 5, and we just follow the directions, because what are we trying to do? We're trying to make the 4 by itself. We need to add 1 on each side. So when we minus the 5 and plus the 1, my final answer is 1. And now we write our commutative property. Minus 4 is equal to minus the 5 plus the 1. Or it can be minus 4 is equal to plus the 1 minus the 5. So this is about understanding that they can be in any order. So when we look, here's my question. We have the 5 and we want to subtract the 4. When we subtract the 4, we need to substitute minus the 5 plus the 1. So I'm going to substitute, take away the 5, and we're going to add the 1. And notice when I have it, I'm going to move my fingers up. So I move my fingers up like that. That's what I'm going to do. Move my fingers up. And my final answer is 1. And then we do the next one. Here is my next one. 3. Again, we're going to subtract 5 from 3, minus 3, 1, 2, 3. And what are we going to do? We're going to do? Well, we know what our formula is, right? We know what we're going to do is we're going to do minus a 3 minus 2 equals minus 5. That's a very common pattern. So the common pattern is to do this. So what we're going to do is we're going to isolate the variable because we need to isolate the 3. Minus the 3 is what we're going to isolate. So what we do is we need to add the 2 on each side of the equation. As we add each side of the equation, right, we notice that when we take away the 5, that's not enough. We have to add the 2. So my final answer is 2. So here is a commutative property. It's minus the 3 equals minus the 5 plus the 2. Or it can be minus the 3 equals plus 2 minus 5. So that's what commutative property means. Means that it can be in any order. In abacus, we can put it in any order because this is the same. It's different than the mainstream math. So here is the question again. When we move, what we want to do is we want to have our number, which is 5, and then we need to take away the 3. Notice I can't take away the 3. So we substitute minus the 5 plus the 2. So with our index finger, move the top bead away from the beam, and then we use our thumb to push the 2 beads up to the beam. So my final answer is 5. I'm sorry, 2. Yeah. All right. So then we have this one. I think so what I was doing is this was actually going to be a lamination. I'm going to laminate these worksheets, and so what I was going to do is I was going to be double sided, and it's going to be like if you're subtracting 2, you can take away the 2. So here is the other question, right? I have 5, and I want to take away the 2. So again, if I have 5 and I want to take away the 2, there's not enough beads to take away the 2. So what are we going to do? We are going to use our formula, right? We're going to isolate our variable. We're going to take away the 2. We have to subtract this 2. What we need to do is we need to make the 2 by itself. We need to add the 3. When we add the 3 to each side, we have our formula. We have minus the 2 equals minus the 5. This is not balanced. So what do? We have to plus the 3. What we're going to do is we're going to minus the 5 and plus the 3. My final answer is 3. To write the commutative property, it's minus 2 equals minus 5 plus 3, or minus 2 is equal to plus 3 minus 5. So again, our question is 5 and then minus 2. When I minus the 2, there's not enough. So I need to substitute minus the 5 plus the 3. So I'm substituting minus the 5 plus the 3, and I move it up together. And my final answer is 3. 1, 2, 3. And then we're back to the last one, which is subtracting 1. When we subtract 1, it's the same way. So notice that there is a number pattern. The pattern is that we know how to make a 5, and we know our pairs when we make a 5. So this is the to isolate the variable. When we isolate a variable, right, we have to make the 1 by itself. We need to add 4 to each side. So if I do minus 1 equals minus 5, what are we doing? Well, if you notice, this is not balanced. So if it's not balanced, what are we going to do? To balance it, we need to add the 4. Why are we doing that? Because if we take away the 5, there's not a that if we take away the 5, it's not a balance, right? Because what are we trying to do? We're trying to go through our question. So here's our question: 5 minus 1. So I have the 5 and I take away the 1. When I take away the 1, there's not enough. So what do? I substitute minus the 5 plus the 4, plus minus the 5 and add the 4. So my final answer is 4. 1, 2, 3, 4. When I look at my commutative property, I want to be able to make sure that I can write it both ways. Minus 5 plus 4, or plus 4 minus 5. Anybody have any questions? If not, I can continue on because I got. Oh, so that was the thing. So I think this is ready for to be laminated. And so what I was going to do is I was going to have it both double sided. So it's going to be like this. If I'm adding the 1 and I flip it, we have subtracting the 1. So it would be the 5, utilize the 5 bead, adding the 1 and subtracting the 1. Adding the 1, subtracting the 1. I think that's going to work out. And then, yeah. But the biggest thing is to make sure that I have the verbiage right, the copy right. Because if I laminate it, it's going to be stuck for a very long time. Thank you for the follow, Cursed and Crotched. Let me know if you have any questions. I don't know if anybody else is here. Okay, so Lady J, isn't it late for you? It's like late, isn't it? It's like really late. Okay, so we can do the tens, or what are we going to do? Anybody have any specific questions? Do you have any specific questions, Lady J? This is 9. Because this is actually, oh, I see. I did start it. Okay. No questions? Okay, now you're just watching me go through my papers. We can do, yeah, we'll do that. And then we could do this 7, 8, and then 9. Anybody have any questions? I don't know who else is here. So, but this is with the idea. The idea was to be able to go through and go through each one. Oh, you know what? I'm going to do back and forth. Maybe that will be easier. So there's that one. This one. There's this one. And then there's 5. 4. 3. 2. And 1. Okay. So that's it. I mean, that's all of the worksheets that I have. Not all. That's not all of the worksheets that I have. I have more. It's just for right now. Because I want to do is I want to create a product. This is the product. And so what we're doing is we're going to subtract. We're going to add the 5. I'm sorry. Excuse me. I'm going to add the 9. So why am I going to add the 9? This is where we start talking about, it's really interesting. It's the 10. So here is the 9. I have 9 and I want to add another 9. So there's not enough beads to add the 9. We know how to make a 10. This is where making a 10 comes into play. So after we make a 10, we know that adding the 1 and the 9 is equal to 10. That's what we're teaching the kids. So what we do is, again, we're going to supercharge it. Level up. Oh, excuse me. I'm going to level up. So that means we're going to isolate the variable because we need to add the 9. Because we need to add the 9, what are we going to do? We need to subtract 1 from each side. So 9 equals 10 minus 1. Because if I just take away the 10, if I just equal to 10, that's too much. So I need to minus the 1. So I will need to plus the 10, right? We know when we add the 10, it's a 1 and a 0. 10 is 1 and a 0. So we're going to do plus the 10 plus the 1 and minus the 1. So my final answer is 18. This is why rewriting the commutative property would be good. Because when we get to bigger numbers, we need to know that we need to be flexible. So 9 is equal to minus the 1 plus the 10. And so if we did it again, we have 9, we have 5, 6, 7, 8, 9. We add the 9 and then we substitute plus the 10 minus the 1. So if I had 9, I'm going to plus the 9 is equal to plus the 10 minus the 1. Plus the 1 and then minus the 1. So my final answer is 18. Okay, that's the second time within like this is the second time within the minute that I've yawned. I'm getting very sleepy. If there's no other questions, I am going to end this live. Oh, I wish I could go further, but my energy just kind of plummeted a little bit. I think I gotta go take a nap. So If there's any other questions, let me know. If not, I am going to end the live. Are we okay? Thank you so much for liking the live. But I do need to end it. I'm getting a little sleepy and I can't focus. Anybody have any questions? Yeah. Excuse me. Anybody have any questions? Okay. If there's no other questions, I am going to end this live. Whew. Goodness. Okay. Thank you, everybody, for joining. Ooh, that's not what I want. Thank you again for joining, and I will see you in the next live. Uh-oh. Oh, please. There we go. There we go. There we go. There we go. All right. So, if there's nobody else, I am going to end the live. Any questions? No? Okay. Have a good day, everybody, and I will see you in my next live.